Hi friends, welcome back to my channel, and today I'm gonna show you how to do the first question of exercise 11.2 of the chapter Constructions of the Grade 10 Maths textbook. The first question, as it is being shown, is to draw a circle of radius 6 cm from a point 10 cm away from its center. Construct the pair of tangent to the circle and measure their length. So we can directly start the construction. So first, we need to take a compass and then accurately take 6 cm on the compass. I prefer using sharp pencils because in a sharp pencil we can get such accuracy that is needed for the best construction. So we take a point on the page and then we draw a circle of radius 6 cm on the page. Like that, yes. Then the next part of the question. From a point 10 cm away from its center, construct a pair of tangents. So for that, we need to take 10 cm on any part of this page from this point center of the circle. So we can name the center of the circle, say it as O. And then we can take 10 cm from this center to any point outside the circle. So for that, we can just take a scale and then measure accurately 10 cm the page. 10 cm from the point O, we can name that point, say it as P. Here I take 10 cm here. And then we draw a straight line from O, 10 cm from O, and we can name it as, say it as P. We can name the point as P. We can name the point as P. So we can, after naming it, we can just accuracy, just check the correct length of the page. The line segment is correct 10 cm. And then we have to bisect the line segment such that they are equally divided. Like say if this bisect in the middle point is M, they must be equally divided, that PM is equal to MO. So for bisecting, we need to take more than half of the line segment, draw an arc on the top like this, and draw an arc on the bottom like this. With the same distance in the compass, we should keep this compass on the point P outside the circle. On the point P, and draw another two arcs on the top and the bottom such that they intersect the first arc at 2 points. Then we need to join these 2 points so that we get a straight line perpendicular to the first PO. There also we need to use an accurate sharp pencil for better accuracy and for a better construction. So we can just draw a line joining both of them and check whether PM is equal to MO. So here we get PM is equal to 5 cm and MO is also equal to 5 cm. So we can name them as M. Then after drawing the perpendicular bisector of PO, we need to take M as the center and PM as the radius, and then we have to draw another one circle intersecting the first circle at 2 points. So we can take M as the center like this here, as I'm being shown. As it's being shown, we can take M as the center here. Point M on the center. And then with MO or PM, since both are equal, taking them as a radius, we can just draw a circle like this, intersecting the first circle at 2 points. Say it is S and T because I name it as S and T. So as you can see here, these 2 points, that intersecting points, I have named them as S and T. Now we need to join PT and PS such that PT and PS are the required tangents to the circle from the point P. There also you need to get accuracy. You must be very accurate with a sharp pencil to do such point joining works. So here I've joined PT and then the next is to join PS. So for that also you need to use accuracy here. As you've seen, I've drawn PS and PT such that PS is equal to PT because they are equal tangents from a point P outside the circle. Now we can just simply join OT, where OT is the radius to the circle. That also must be intersected on the point that's in which the second circle intersects the first circle at. So just we can join those parts simply but accurately, like we get correct 90-degree here, because a tangent is perpendicular to the radius. So we can just check that out with a with a protractor like this. Yes, we get 90-degree perpendicular, so it proves that they both are tangents to the circle. Now we can, as the question says, we have to measure their length. So simply by measuring the length, we can just measure the length of the circle, length of the tangents. Like we need to point out that point, and from that point we need to join. I get here accurately 8 centimeter length. So the PT for me is 8 centimeter, and the same way I have to measure PS, and here also I get 8 centimeter, so it is 8 centimeter. The next part in this construction is to draw steps, is to write the steps of this construction. So as this problem goes, we can simply write the steps in our own ways. So here, the most probably and appropriately, the first step is to draw a circle of radius 6 centimeter and measure PO is equal to 10 centimeter point outside the circle. Then bisect it and let M be the midpoint of PO. Then, with M as the center and PM as the radius, draw a circle intersecting the primary circle as the points S and T. Join PS and PT such that PS and PT are the required tangents. Then the length of the tangents PS and PT is equal to 8 centimeter. Now here we have to do justification for a problem. There are 2-3 methods to do justification according to the given numbers. Here we have got that the length of the tangents. Here we can either prove that the length of the tangents is equal to 8 centimeter, or we can prove that this PS and PT are tangent to the circle. To prove whether, to justify whether PT is equal to 8 centimeter, we use the Pythagoras Theorem, where we get POT to be a triangle in which angle PTO is equal to 90 degree. So we can take PO as the hypotenuse of this triangle, and using the Pythagoras Theorem we can find PT. So we get it most appropriately as 10 square minus 36 6 square. So we will get it of course as 64. Root of 64 is 8. So we can prove either that PT is 8. The other method is to prove that PT and PS are tangent to the circle. That is also quite easy. Now we have to take this semicircle PMOT. So this is a semicircle, right? So here, when this circle, this is a semicircle, this angle 90 degree which we drew using the tangent rule is of course angle in a semicircle, and it's rightly and accurately has to be 90 degree. That's what the angle in a semicircle rule says. So of course angle PTO is supposed to be an angle in a semicircle, so it's of course 90 degree. Then we can say that PT is perpendicular to OT. So if OT and OS are the radius of the circle, then of course PT is the tangent to the circle. So that is a second justification that we can do for a single problem like this. So you can do either 2 types of justification, either finding the length or proving that PT and PS are the tangents to this circle. So I would say explain how to draw this figure once more. So first we will have to draw a circle of radius 6 centimeter with O as the center. Then we have to measure 10 centimeter, PO is equal to 10 centimeter outside the circle. Any point does not require any perpendicular or parallel points. You can just take it anywhere, whether it's over here or here or here or even here. So I have taken PO is equal to 10 centimeter over this side. Then we just bisect the line PO such that M is the midpoint. So we can just calculate that PM and MO is 5 centimeters. Then with M as the center and PM as the radius, we draw one more circle intersecting the first circle at S and T points. Then if you're joining PS and PT, we get that PS and PT are the tangents to the circle. So we can do two justifications here. The first one is proving the length of the tangent, otherwise proving that PT and PS are the tangents to the circle. Thank you for watching my video, friends, and subscribe to my channel such that you get all the explanation of all the questions that I'm going to prove from now on. Thank you.